Other polygons is sort of a catch-all category. I talk about diagonals here. I talk about a little bit interior, exterior angle stuff. Most of that's in angles, though. Check out those related videos. And it's just the stuff that we don't typically deal with as much. Now, I want to talk about one little special topic before we jump into an on-screen problem about perimeter, which is diagonals. So if I have a hexagon, 1, 2, 3, 4, 5, 6 sides, and they ask me how many diagonals it has, it's a lot of trouble for people. There is a formula for it. One I wouldn't bother to remember. What I would do instead is pick a point to start and draw diagonals. Remember, diagonals just go from point to point, corner to corner, in a shape without being on the edge, right? So I can't draw one from this corner to this corner because that would be on the hexagon. Same thing here, right? So each vertex of a hexagon will have 3 diagonals. There are 6 vertexes. So that makes for 18 possible diagonals. There is a second step though. If I go all the way around, let's say I start here, right? And I've got a duplicate, right? Now other 2 are fine. But then if I move over to the next one, I had to reach a little bit for this orange marker. If I go over to this next one, guess what? I'm going to run into another duplicate. So essentially, this is a great strategy. This is what I use, what I recommend you use. But you double count every diagonal, so you have to make sure at the end, 6 times 3 is the number of possible diagonals, but you got to divide that in half because you're double counting each diagonal. Okay. That's all there is to that. There's practice problems in the book that I recommend you look at. They kind of like this question these days. Let's go ahead and jump into these weird perimeter questions, which they absolutely love. This is a common question type, this perimeter of a weird shape. You have missing dimensions. You miss this, you're missing this, you're missing this, missing this, and they ask you what the perimeter is. Now, there's a key to this question. Everything intersects at 90-degree angles. There's 2 ways that they'll do that. They'll either tell you that or everything is either north, south, or east, west. It's a bad S. Okay, so because everything's at 90-degree angles, I'm just going to go ahead and mark this up. You don't need to do this when you do the problems, but just when I explain it, I think it might be helpful. These 2 things are at 90-degree angles. That means they're exactly 180 degrees apart, right? 90 here, another 90. That means these lines are parallel. This is also parallel. This is parallel. And this is parallel. Now let's look at the vertical lines. I'm going to change pen colors real quick. The vertical lines are all the same, right? Parallel, 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 parallel. So everything is parallel or perpendicular. Things that are parallel never get any closer or farther away. Oops, try that again. So it's kind of like this, whoop, like this, whoop. Sound effects are added. And then whoop, straight up, then straight down. Essentially, this will have the same perimeter as a rectangle like this. Why? Well, even though the area will be smaller, we still have to go up 8, right? Because we're going 5 plus 3. And then because it gets no narrower or wider on this side, this has got to be 5 plus 3. And over here, this has got to be 12. So what's our perimeter? Well, it's 8 plus 8 plus 12 plus 12. That's really all there is to these. It's going to be the same on each side. So if you can find the whole left side, that left side will be the same as the right side. If you can find the top, it'll be the same as the bottom, and vice versa.